everybody. My name is Shizong Xu. I'm from Department of Information Management at Sina University, Taiwan. This is my topic. The fuzzy similarity metric model for interior design drawing recommendation. This background, because cosine similarities major function fail to measure mixed qualitative and quantitative scale at the same time. For interior design drawing retrievals, the purpose of this study, the fuzzy cosine similarity metric models for mixed measurement scale is proposed and applied to a recommender system for interior design drawing retrieval. The presented recommenders system consists of a virtual reality-based CUI systems, database system, and the proposed similarity metric models. This is a research method. In this contains a best recommendation system. There is a set of classified historical case profile and a CUI profile characterized by a set of features rating pairs. In our previous study, the set of historical case profile are represented by an n multiple by n binary case feature rating matrix R M n, where Fij is 1 if the ice pattern has just features and 0 otherwise. The set of CUI profile is represented by a CUI features rating vectors, where FQI is 1 if PQ has just features and 0 otherwise. The vector representations of the CUI profile PQ in the historical case profile PGI1 can be used for computing similarities value. The case for which the system wants to recommend to the user is referred to as the target case. A nominal variable is one that has two or more categories, but there is no relation of order or grades between the categories. In this study, nominal features are modeled as degenerate fuzzy sets. For each value, V of the feature, a fuzzy set with a membership function is shown as follows. Where X is the original assessment of features, V is certain category of features. And if an original assessment X is equal to certain category V, the membership degree of mu X is 1 and 0 to the others. When measuring an ordinal variable, we first determine ranking orders of the variable and then transfer mapping value for each ordinal ranks respectively. Thus, the ordinal scale can be converted into a set of linguistic terms. The set of these linguistic terms can be converted into their corresponding triangular fuzzy numbers, DFN, as shown in Table 1 and is at Figure 1. An interval scale is a numerical scale that has that property of equality of the intervals, but they do not have true 0 points. Absolutely zero points. Even if one of the scale varies happen to carry the name zeros. Temperature is a good example of interval scale. In Table 2, we show an example of the variable, the temperatures, structured as fuzzy interval scale of cold, medium, and hot. In addition to possessing all the properties of nominal, ordinals, and interval scales, a ratio scale has absolute 0 points, which indicates the absence of the quantity being measured. Height and weight are example of a ratio scale. The table 3 and figure 2, table 3 and figure 2 shows an example description for the ratio scale variable height and present fuzzy numbers associated with the linguistic terms. And this proposed fuzzy similarity metric models. Step 1, translating various measurement scale into fuzzy measurement scales. Step 2, computing the local similarity measures. This is a cosine similarity measure for fuzzy nominal scale. Let's denote the feature similarity between the historical case Cj and the Cooley case Q with regard to the feature Fj. If the feature Fj is a nominal variable, the local similarity between two J's features ratings is given by it assign value 1 if the two features match and the value 0 otherwise. This is the cosine similarity measures for fuzzy ordinal interval and ratio scale. Step 3, computing a global similarity measures. Definition for global similarity function. Global similarity measures aggregate the local similarity measures into one similarity values. That signs denote the global similarity between the historical case Cj and the Cooley case Q, and then the global similarity measure can be derived by the weight summation of the local similarity measures, where the local weights are defined by expert, assumed to be a quantity reflecting level of importance weights of the corresponding features. Sim is the local similarity function between are the values in J in the Cooley and the retrieved case respectively. The step 4, sorting the global similarity values in descending order. These are architectures of the proposed recommender system. During requirements analysis stage of the interior design drawing development life cycle, existing methods used in developing interior design prototype drawing usually lack sense of realism as well as require the designer and the consigners several iterations of the time-consuming design reviews. To solve this problem, we developed a virtual reality-based recommender system for interior design prototype drawing retrievals. The proposed recommender system consists of virtual reality-based Cooley system, a data-based system, and the similarity metric models. The architectures of the proposed recommender system is summarized in Figure 3. Numerical case study. Step 1, collecting historical case, the case database. Step 2, tracking features of collected case. Step 3, establishing of contents profile and Cooley profile. From collecting case features rating and Cooley features rating, designers' content profile can be represented by case feature rating matrix. Each row in the matrix is the vector representation of design patterns, as shown in Figure 4. The user preference Cooley can be described as the following: feature value pairs. As you can see, as shown in Table 4. By applying the local similarity measures signs, the similarity between features of all cases in the case database and the curly case can be calculated. Calculation should for computing local similarity measures of curly Q and case C1 is shown in table 15. The global similarity function measures the similarity between each of historical cases in the case database to the new queries. Suppose the weightings are equally weights, each being equal to 1, then the global similarity measures can be obtained. This is the conclusion of features research. In these papers, new fuzzy consign similarity metric models were proposed and used in the recommenders system for retrieving interior design drawing. Finally, a case study numerically demonstrates that the proposed fuzzy cosine similarity metric model is effective and feasible to use in the recommender system. In the future, more reference design cases will be collected and stored in the case base so that availability of choice case can be increased. Also, we will apply other similarity measurements functions to the metric model of the recommender system to make comparisons among the result and obtained in this study with the result less obtained with other similarity measurement function. Thank you for your listening.
Questions, please? So we have pretty much time if there's a chance. Can you show the second to the last slide where you show the features? Right, the previous one. No, that'll be the next one.
Number 3. Number 3.
No. No, you go to the very last one.
The very last. The third slide from the last. The next one.
No, go down. No. There's a table where you showed all the features you used. There were 15 features.
Next. Next.
Yeah, this one.
Oh, this is.
So, I'm interested in, did you consider that if you do interior designs, then that means you have some customers. The customers might live in different places. For example, the customer might live in Japan, Netherlands, Taiwan. And do you have a feature to consider this kind of background information about the purpose of the design? Did you consider that right here? Or do you think you will do that in the future?
Probably doing in the future. This is a very good question. We see what can find.
There are so many possible features you can consider to add when you implement a query and information retrieval system. Thank you, Professor Chu.